Hello everyone. So our today's topic is random forest. Random forest is a subset of bagging. But what is bagging, you might ask? So uh, s- to explain bagging, I'll use an example. Say, for example, you are going to a shop to buy a watch for yourself, and your family goes with you. So when you try on watches, you take their opinion that is this watch looking good or is that watch looking good. Everyone gives their opinion that yes, this one looks good, this one does not look good. So that is a yes, no, right? So you purchase the watch which gets the majority, means where the majority of the family members of your family members say that yes, this one looks good. You buy that watch. The similar concept is used in bagging. Okay, you have multiple, algorithms running the same data like logistic regression, SVM in case of classification type of problem, and some other also, and decision trees, right? And you combine all those results. Either you take the average if it is, regression type of problem. Continue. You want a number, then you can take average, or if you know that in the output of a certain model like decision tree algorithm will give a better output than say SVM, then you can give more weightage to their answer. So you can do weighted average, or you can do just pooling, sorry, you can do just the max of that whatever, yes or no, the maximum of whatever the answer comes. If it is yes, then that will be your answer. So that is the concept of bagging. But in random forest, what you do when all those models like SVM, decision tree, and logistic regression, whatever you have in bagging, you replace them with your decision trees, then it is called random forest. Okay, and there is one important concept in random forest called column sampling. In bagging, you might know that in bagging, row sampling happens. Okay, and what is row sampling? That see, you have these many 6 rows, then at every uh, decision tree, you have multiple rows. Either they can be repeated, or you drop some rows. Like here, the there is only 4 rows, but normally you have as many rows as you have in your original data set. But that is not, a universal fact for that. Okay, but you can use as many rows, but the default is you have all that many rows that you have in your original data set. So let's say you have 4 rows, but here we have R1, R2, and R2 is again repeated, and you have R5. We have omitted R6, R4, and R3. We have just R1, R2, and R5 here. In again, decision tree number 2, we have R3, R4, R6, R1. We have omitted R2 and R5. Similarly for this, so you have random random rows, and when you generate these random rows per tree, then you do column sampling. Means you pick random columns from your sample, and then apply the decision tree algorithm on that. And after that you apply, then again if you have another layer of decision tree, then again another column sampling happens there. So this will lead this no this makes the whole random forest algorithm very robust and invariant to high variance. Okay, this is the very core of random sampling. And whenever you get all the as answer, you can do the majority vote for classification or average for regression, as I told you, and that becomes your final answer. So random forest is one of the two most important machine learning, statistical machine learning algorithms you will learn. And the other one is XGBoost, which I will cover in the next video. So this is how random forest actually works. Thank you very much, and this is it for today.